Okay, there's your warm up. I need my microphone. Okay, right here, tangent. So I'm going to zoom way in that upper right hand corner, which you can't see yet, but you will now. Okay, so we have, anybody remember asymptotes? Right, the graph will get closer and closer and closer, but never actually touch. That's what an asymptote is. So we got asymptotes on this sucker. I'm going to draw in so you can see them. Ooh, that's a large one, but that'll work. You too should draw them in. Then we'll talk about why they're there. So draw those in real quick. It's right after the sine and cosine if you're looking. You good? So here's my question. What is this value right here? Look at the graph. They're super tiny, right? But this is 0. This is pi right here. So in the middle, it should be a little bit over. Pi over 2, right? So this is right at pi over 2. If we think about the old unit circle, at pi over 2, so remind yourself what tangent is. It's circled on there, which I don't want to have it circled on there. So tangent is right there, right? Tans y over x. So if I'm at pi over 2 and I'm doing tangent, what do I get when I do y over x? What's 1 divided by 0? Undefined, right? So that's why in the tangent graph, we have all these parts that are undefined, right? And that's what forces the tangent graph to slowly increase all the way, right? So that's increasing. What's the domain, not domain, what's the range of this tangent graph? Does it go up and down forever? It sure does, right? So interval notation, you guys got to remember all this crap. Interval notation is like this. If you write it in set builder notation, you can close that computer. Set builder notation, it looks like this. Y such that y is an element of all real numbers. Right? Written in gigantic. Get your packet out. Start writing. Yeah, you don't even have a pencil. Ah, there it is. Excellent. Okay. So that's how you write it. Set builder. This is interval notation right here. And this is set builder. Okay. Just so you can remember the difference, you got to know that. All of you juniors out there, you're going to take SAT. It's to your advantage you're currently in pre-calculus because there is pre-calculus on SAT. The one thing about SAT is that kids forget 1/3 of it is geometry. And that was a long time ago if you're a junior in pre-calculus, right? So you got to go back. Khan Academy has really good stuff. around SAT practice. If you hire a tutor, you're going to spend like $2,000. That seems silly to me. Like I tutor on the side. I don't tutor SAT because like I feel like I'm taking advantage of people. Because it's too expensive. Take a class. Like I took Princeton Review and learned how to take the test. And for me, that was the most beneficial. My SAT score went up 100 points after I took the class. So I learned how to take the test. Okay, so we just talked about the vertical asymptotes right there, right? It does not have an amplitude. But when we graph this thing, we're going to use the A is going to give us the ordered pair like here and here on the graph. So that's what our A is going to be used for, okay? And we'll talk about it here. Period for tangent is pi over b. So not 2 pi this time, but pi over b. The asymptotes are odd multiples. On this graph right up here, they're odd multiples of pi over 2. So odd multiples, this would be like 1 pi over 2. The next one would be 3 pi over 2. I don't know how helpful that is. We'll talk more about it when we graph these things. But you can write that down. It might help someone. So when we do that interval thing and we figure out what the period is, we divide it by 4. The asymptotes are on every other one. So we're going to graph a little on the negative, a little on the positive with these things. So I just remember this whole concept. I remember I do every other one on the interval as my dotted lines. Okay? So we're going to come down here. We'll do it on a new page right here. All right, I'm going to copy, we'll do number 11 first. So you can grab another piece of graph paper if you want. You can also do it on the little grid where 11 is. You do whatever works for you. So remember our amplitude is 4, but there is no amplitude, right? That just tells us where the dots are going to be, lower left and upper right. But for my period, I'm doing pi over b, so in this case just pi. Technically pi over 1, right? But I'm going to do, my period is pi, and then I'm going to multiply by 1/4 to get my intervals. When I multiply by 1/4, I get pi over 4. What's the next one after pi over 4? 2 pi over 4, which reduces to pi over 2. So when we graph this thing, we're going to get a graph in the middle. Actually, let's make that bigger. So we're just going to graph like regular old coordinate plane. And we're going to put, so I'm just going to count out here. So I'm going to go 2, 4, -2, -4. So this is pi over 4. This is pi over 2. This is negative pi over 4. This is negative pi over 2. I'm going to use this for, I'm going to go up 1, 2, 3, 4 units. I'm also going to go down 1, 2, 3, so -4 down here. So when I talked about like skipping one for my asymptotes, right? I'm not going to do an asymptote here, but I am going to do one right here, right? So dotted line at negative pi over 2 and positive pi over 2. Which I will draw in. I think the asymptote should always be dotted personally, but honestly, it doesn't really matter. So when I start graphing this thing, I always want to start, if it's positive, I start lower left, make a dot. I also make a dot right at the origin, and I make a dot upper right. Okay, so if it were negative, what would happen to this graph? It goes the other way, right? So if we had a negative right here, right, if this were a -4, then this dot would be over here, here, and here. Okay, so we'll definitely do one like that. But, so draw your graph, something like that, and you're good. Right, we're just doing one period of it. So there you go. We're going to do 12 next. That's a -1. Do you want to try it on your own? Or do you want me to do it? My super talkative third period. Right, so there's 11. We do 12. Thank you. We do 12 for the period. We have pi over 1/2, which is copy dot flip 2 pi. Then to get our intervals, we divide by 4 and reduce that fraction. So we're going to have intervals at every pi over 2. Okay, then I can make my graph. So what's after pi over 2 then? Pi, right? 2 pi over 2, which reduces to just pi. Negative pi over 2 and negative pi. Okay, my dotted lines go on pi and negative pi. And then my graph, instead of starting lower left, it's going to start lower right. And our amplitude is just 1. I'm going to go down 4 spaces just otherwise it gets kind of jumbled up. Right, because we're just kind of changing the scale right there. That's legal math move. Right, so we go lower right. And it finishes upper left. Like that. So if I ask you what the range was of this in interval notation, you'd have to say parentheses, negative to positive infinity. It was kind of an ugly graph, but whatever, it works. Okay, I'll leave that up for a sec. We're gonna let's do 13. Do 13 on your own. If you're confuzzled, I'll do it up here. Right, you can always multiply by 1/4 instead of dividing by 4, especially if it's a fraction already. It just makes it a little easier to cope with. If you need more graph paper, you can always grab more graph paper. Right, I don't care if you do fraction or decimal, doesn't matter. You're both correct. When you guys go to college, you should all get iPads. Makes your life easier. The beauty of getting an iPad in college is you can sit towards the front of the lecture hall, and on this app you can hit record, and it'll record the professor's lecture as you're taking notes, like real time. So if there's a point in the lecture that gets too complex and you need to just stop and listen, you can do that, and then go back later, go into the recording and kind of fill out additional notes if you need to. So it would have been huge for me in college to have one of these. Okay? One last one, and then you get homework time. Start doing 14, that's what we're doing. I'm doing copy.flip right away. As long as you're consistent with your intervals on X and Y, you can do different for X and different for Y, but just kind of count the same, you're fine. What's after 3 pi over 8? 3 pi over 4. Right? 6 pi over 8 which reduces to 3 pi over 4. So we start this slow intentionally because next week we start graphing secant, cosecant, cotangent, and we also start doing transformations of these functions. So we'll take like this graph and move it pi over 4 to the left, and it gets really confusing, so that's why we do a slow start on this. So it's intentional, if you care to know that. Doesn't matter to me. Okay, that's it. So you're just finishing that sheet. It's, I think, 9 through 12 is the end of that sheet. So just finish it. I'm not checking. I'm just going to check the whole sheet on Monday. So make sure you have it all done. So if you didn't finish last night's homework, you're lucky, right? And you get the weekend to do it. That's it.